The central problem in teaching English for academic purposes is that human intuition is a highly flawed metric. When faced with an overwhelming mass of language data, human instinct fails to provide systematic rules. Even expert educators and native speakers cannot reliably articulate exactly why one specific phrase is preferred over another in a given academic context. Relying strictly on traditional grammar rules often produces second language writing that is structurally flawless, yet still sounds distinctly unnatural to an experienced reader. Addressing these hidden complexities requires moving beyond intuition and toward a methodology based on the direct observation of evidence. That empirical solution exists. It is known as the language corpus. A corpus is a massive, searchable database comprised of naturally occurring, authentic texts compiled specifically for empirical linguistic study. The raw inputs of a modern corpus encompass everything from written academic journals and textbooks to exact transcriptions of spoken university lectures and seminars. The premier example of this database is the Cambridge Academic English Corpus. To understand the sheer scale of this resource, the Cambridge database alone contains over 400 million words of verified data. By shifting our pedagogical focus from what is theoretically grammatically correct to what is statistically typical, we can map the invisible rules of academic discourse. The foundational metric for extracting meaning from a massive database is frequency. However, raw frequency presents an immediate problem. The top 3 words in the English language, the, of, and to, make up 10% of any given text, which creates immense analytical noise. Working further down the frequency list filters out that noise and exposes the unique lexical fingerprints of specific academic disciplines. This animated bar chart compares the most frequent nouns found in undergraduate textbooks across 2 fields. In the applied linguistics dataset, the word language naturally towers over other terms. Contrasting that with biology, the distribution completely changes. Now, species and DNA heavily dominate the count. To navigate and analyze this volume of data, researchers rely on a specialized text analysis tool, the concordancer. Concordancing software reorients how we view language, transforming traditional linear reading into vertical pattern recognition. This is achieved through a layout known as Keyword in Context, or KWIC. In this interface, the search term, called the node word, is perfectly aligned down the absolute center of the screen. This enables a dual reading method. Reading horizontally gives you the specific instance of use. Reading vertically reveals the systemic rules of the language. This screenshot of MonoConc Pro shows a left sort, organizing data by words preceding the target node word, thanks. It reveals the noun is overwhelmingly modified by only 3 adjectives, with the specific combination, special thanks, comprising over 2/3 of all cases. Concordancers expose these hidden, systemic preferences that human readers would never consciously notice, even after reading thousands of pages. Moving beyond single words, we identify lexical bundles. These are the prefabricated, multi-word phrases that function as the structural building blocks of advanced academic texts. Concordancers search for these highly variable bundles using wildcard syntax, utilizing the asterisk symbol to stand in for unknown words. This is a screenshot from the WordPilot interface, demonstrating a wildcard search using the query it*that. The resulting concordance lines expose specific phrases populating the center column, such as it is likely that, it is clear that, and it is shown that. Academic writers intentionally deploy these specific lexical bundles to evaluate claims and signal either certainty or doubt to the reader. The statistical finding is clear. In research paper abstracts, expressions of certainty occur significantly more often than expressions of doubt. Mastering these specific lexical bundles helps bridge the gap between technical accuracy and the authentic style of an expert writer. Pushing the analysis past structural grammar into deep meaning brings us to collocation, the strict tendency of certain words to frequently pair together. Collocation introduces the most advanced concept in corpus analysis, semantic prosody. Semantic prosody is the connotative meaning a word acquires strictly through its habitual co-occurrence with other specific words. The word commit exemplifies strong semantic prosody. The corpus proves it carries an unfavorable implication, overwhelmingly bound to negative nouns like crime, murder, and mistakes. Similarly, rife connects almost entirely to negative contexts, exhibiting highly unfavorable semantic prosody. Firmly, even if a word is used with perfect grammatical correctness, using it with the wrong prosody will instantly mark the text as unnatural to an expert reader. Corpus linguistics is not restricted to the rigid structures of written journals and textbooks. It accurately maps spoken language through databases like MyCase, the Michigan Corpus of Academic Spoken English. This table from the MyCase research shows a quantitative analysis of spoken corpora, revealing that academic speech relies heavily on its own distinct formulaic expressions. High-frequency spoken formulas dominate this list, exposing conversational bundles like "I'm gonna go" and "the thing is." In a lecture setting, a phrase like "I'm gonna go over" functions specifically as a tool for task management, not as an expression of physical movement. This proves that even spontaneous spoken academic discourse operates on a rigid, mathematically provable architecture that differs entirely from written text. Ultimately, concordancing changes the student's role, replacing the passive reception of rules with the active, evidence-based discovery of patterns. This pedagogical shift is known as data-driven learning. This methodology provides an open-ended supply of authentic language data, tailored directly to the learner's specific discipline and exact needs. Because of these tools, students and instructors no longer have to guess at what sounds natural. True linguistic fluency is no longer an invisible art. It is achieved by making informed choices, guided firmly by the mathematical reality of expert practice.